All right. So yeah, you're welcome to today's class. Of course, my name is Victor Kok, and today we are going to be talking about promises in JavaScript, RESTful APIs, and Express.js, right? Okay. Then these are the three topics I'm going to cover, right? But I'm going to go um, into each of them, at least the basics, and then we'll talk about what promises are, what RESTful APIs are, how they are being used, right? Then what is Express.js and how it's being used. Okay. I hope you guys can hear me. Is there anybody that's not hearing me clearly?
Yes, we can hear you. I can hear you.
Okay. All right. Cool.
And Mr. Victor,
Yeah.
are we not going to talk about the core concept of Node.js? Like all this read line, child process and stuff like that.
Okay. We are also going to do that, but that won't be in today's class. We'll also talk about those things, right? But then, apart from that, the main essence of the beginner class, right, is
Okay.
to take you through the basics of Node.js, not even the like very advanced topics and the rest, just the basics, and then more of how to use Node.js to write APIs.
Okay.
Yeah.
All
And
right. No problem.
so, but then I would still cover most of those stuff, read line and file system, and all those other modules that come with
Mm,
Node.js. We'll definitely cover
yes.
them. Yes.
All right. All right.
Okay.
And again, okay, don't worry, after the class.
You have another question?
Yes, yes, that will be after the class.
All right, no problem. Okay. So with that said, let's move to VS Code, right? So what is a promise, right? And I think I mentioned something about promises before, but I didn't write the code to it actually, right? So, or I don't know, I can't remember, but I think I mentioned it. But then let me go over it, right? So a promise is simply an object that represents the completion or failure of a particular operation, right? Or a particular task. So it's used is an object that is returned when um when the promise, right? Or when whatever you're maybe trying to get a result from is being completed, right? But a promise is different. It has different states, right? It's not just like calling a function normally. A promise has different states. So the state can be pending or fulfilled or rejected, right? So those are the three different states of a promise. So while the promise is pending, it means it has not been fulfilled or it has not been rejected yet. But then if a promise is fulfilled, right, then you would get the results from that promise. But then if the promise is rejected, then you won't okay, you get the reason why that promise is being rejected. So the result of the rejection is the reason why the promise didn't actually execute properly. Okay. All right. So we are here, and um let's see, how do we create a promise, right? So how do we write a promise? So first way to write a promise is, okay, the default way to write it is by declaring it as an instance of the promise object, right? So you can say, I hope you guys are seeing my VS Code. Okay, it's tiny, so let me make it bigger. Let me remove this sidebar. Okay, right. So let's see. Right. So I'll just call this maybe my promise. Excuse me. My promise equals to, right? Let me just call that my promise, right? Then I'll say my promise equals to new promise, right? New promise. Now, this promise accepts a function as its argument, and the function accepts two parameters, right? Which is a resolve and a reject. The resolve part is called when your promise is being resolved, like when it gives out the desired result, right? But then the reject part is being executed if the promise didn't return what it was supposed to return, or what it's maybe it's there is an error, right? And then you want to return that error to the function that was called, right? Or to the function that's called that promise, or to the code that called that promise, right? So you can use the reject to do so. So this is how it works. You'd say promise here, then I said in here you pass a function, whether it's an arrow function or a normal function, it is going to work out. So say resolve here, comma, reject, right? Then in here, you can then write whatever you want to do. If you want to resolve or you want to reject a particular for that particular promise. For example, I could do something. I could say um resolve hello, right? So um this particular promise is going to resolve, or and what is what okay, and another thing, how do um promise is also part of asynchronous programming, right? So what is asynchronous programming, right? So um remember when I talked about the restaurant guy, right? And being able to serve multiple people at the same time, right? Or having people stand in a queue, right? So serving multiple people at the same time, right? Without blocking anybody, stopping someone, right? Stopping who is on the line, or not even having a queue, just people sitting on their different tables, and then whoever made an order and his food is prepared, you just serve that person, right? That's how similar to how an asynchronous code works, and also how promises work. So promise is just mainly try it resolves your code, right? It's promises just makes it simple to either resolve or reject, get a result from a code if what you're looking for resolves to true, or if there was an error, for example, then you can call the reject, right? So I'm going to explain this more in with an example, or with more examples, right? This is a simple way to write a function, right? And then if you want to resolve that particular function, or to call that promise, you would say um my promise dot. So for you to get the result of this promise, you use the then, right? Promise dot then, and then inside that then, you can pass to um you can pass two functions in there, or two callback functions, right? But I will just pass one. Just say maybe res, for example, console console.log res. So what happens is once we call this code, right? This code is going to, when we call this promise is going to first have um the state of pending, right? Then once the resolve is called, so this function would then have this promise here would then um print out this result, and then the state of this promise would be fulfilled or resolved. So if I call that here, I'd say node index. It brings hello, right, from that particular promise, right? But then what if I called reject instead? Reject, and I try to run this code. Okay, sorry, I tried to run the code. It's going to say something that there's an unhandled promise rejection here, right? This error originates either by throwing inside of an async function without a catch block, or by rejecting a promise which was not handled with .catch. A promise rejected with the reason hello, right? So why it's showing this is because when we call the reject, we didn't actually um we didn't handle that reject at when we were trying to use that promise. We didn't handle if the promise was going to be rejected, right? So there are two ways of handling a reject on a promise. And the first way is by passing another function here too as the second callback function for this dot then, right? So you can do this comma, then you write err, just that to represent error. Then you would say console.log console.log let me just say error, then err. So if we do that and we come back here and run node index, you see now it is not throwing, it's not throwing a full error, right? Like it's not throwing it as a full exception. It's throwing it as an error that we've handled here. You see, it's giving us error and then the reason for the error, which is hello, for example, right? We can use this to create something like maybe a code that resolves when we have an even number, and then if we get an odd number, right, then it should reject. We can do something like that, right? So if we want to create that similar code that you can use to handle a promise, right? Resolve, let's take for example, for even numbers, it should resolve, but for odd numbers, it should reject. Something that's close to what we already know. I can do something like this. Function um, check if even. Check if even. Then in here, I'll just give this NUM for number. Then down here, I would say it should return a new promise. It should return a new promise. Resolve. Oh, sorry. Resolve. Reject. Okay. Then in here we can then write the logic to check if the number we are passing here is an even number. We should resolve to yes, this is an even number. If it's an odd number, we can reject and then maybe call a okay, yeah, we should resolve. Sorry, if the number we pass here is an odd number, right? If the number we pass here is an odd number, we should reject. But if it's an even number, we should resolve. So simple. We'll just say if if number percent 2 is equals to 0, then we should resolve to um even number. Then else here we should then resolve to, or we should reject, right? Then we'll reject to let's say error, this number is is an odd number. Okay, so we have that piece of code there, right? If what we are trying to do, right, resolves to even, if what we are trying to check, right, the number we are trying to check is even, then it's going to resolve. Else it's going to reject, which is it will try an error that the number is an odd number. So that's what I'm trying to do here. Then if you want to consume this promise that you've made, right, then you'd say check if even, then you can pass in a number there, right? So you can say let's say 22, for example. Then remember I use dot then, and inside here you'd say res and error err. Okay, if it resolves well, we'll console.log res. But if it doesn't resolve well, we should console.log the error. So apart from this way of checking your error, there is another way, right? Which you can use a catch. So let's try to run this piece of code. We do node index. We see that we have that the 22 we passed in there is an even number, right? Okay. So, but let me pass in 25, for example. Then I come back here and run node index. You see now that it's not running the function to resolve, rather it's running the function to reject, right? That's the function that traps the reject, right? Which is kind of like an error. Okay, so this is how you can use your promise. Another way you can um handle error, right, in your promise is using dot catch. But then inside the dot catch, you will still pass a function with one argument, which is the error argument, or the argument for the reason why that particular um uh promise didn't resolve, right? So this is the reason actually why this reject promise didn't um or why this reject promise was called, right? This is the reason. So when you're resolving in your promise, this is the result for that for the resolve, right? For that resolve function. But then if you're calling the reject, then you always have to pass the reason why you're rejecting that particular promise, right? So that's one thing to always note. A promise can either be rejected or be accepted, or those are like the two different states of your promise when it's being executed, right? The first one is pending, the second one is if it's being resolved, then the third is being it's will be rejected. And a promise cannot be resolved and rejected at the same time. It has to be one of them. Either it's is resolved or is rejected, right? So if we print out that error like that, and then we come back here and run the code again, you see, we still have the error the same way we had when we passed in two functions here, the two functions, the resolve and reject handlers. But if we put maybe 24, for example, we come back here and we run the code, you see that it's running the resolve part for the code. Okay. So I don't know, with what I've done so far, do you guys have question on how promises work? This is like the basics of promise, how promises work, basically. Do you guys understand? Hello?
Yes, I understand, but kindly explain. You said the then function can take two callbacks, right?
Yes.
You can either take the two callbacks or without the catch, right?
Yes. So what happens is
So what
if
was the major difference? Okay.
okay, now the major difference with those two is if you have like if you have let's say another dot then here, for example, right? And then this particular dot then has the um resolve handler, let's say resolve handler here, and then the reject handler, which are functions actually. For each of these denable function, right? For each of these denable function here, this is called denable, right? And that's the name they are being called. For each of these, you can handle the errors that handle each that happens in each of these if you're passing two um functions here. The first function to handle the resolve, the second function to handle the reject. Okay, you can always, so for example, if there is an error that happens in this dot then, for example, and then there's um there's a reject handler here, right? Reject handler there, for example, this reject handler will be the one to handle that error. So let's continue. So here, what, I just have one dot then, right? I don't need more of them, so I'll just say um res, okay, I'll just say err for error, and then inside here I could console.log the error. Now I know people might wonder, how is it that why can you have more than one dot then, right? So you can you can transform maybe a data, right? You can transform the result of the first then, right? And then send that result to the next then by using the return here. For example, I can do this, right? I could say return results. Okay, return um RAS, but I want to add something to RAS, so I'll do something like this. Um I'll say results results. Then under here, I could have another dot then, which is going to receive the return value of this first then, right? So I could have another one here. And then here I could say, I could call it data or whatever I want to call it, right? And then I can still return, maybe transform the data and pass it to another enable statement, right? But then I can console.log what I want to do here. For example, I could say console.log um data, for example. If I come and run that code, right? You see, now it's showing results even number, right? Let me keep space here. It's saying results even number. Okay. Now what happened is the results came in as just even number, but then I've added results to what I'm having, and then since I'm returning it, is going to pass whatever I have here to the next then, if there is a next then, right? And then I can maybe still further transform the data and send it to another then, right? But then if I want to handle error that happens only here, I can then pass in maybe a reject handler here as a function. But I want every error that can maybe happen to just be handled by um one statement, right? And that will be this error block here, right? So I'll just put ARR here inside there. And of course, you can have dots finally here, right? You can have finally, but then we'll see how finally works very soon. So, so if I run that, you see result is even, but if I pass, let's say 27, for example, then we come back here, you see that this is actually handling the error, which is this number is an odd number. Okay. So that's how you can use the then, right? Then catch. And then this is how finally works. Um finally is going to execute whether you have a reject or a resolve, right? So I could say finally I'll just say console.log console.log executed, but in quotes, right? So this finally is going to be executed whether or not there was an error, right? So if I run that code now, you see there's an error, but it still shows executed. If I pass something like 26, right? And then I come back here and run the code, you see it brings out, it resolves, right? But then it's also showing executed. Okay. So that's how you can use your finally there, right? Then now this is the basics of how to use your um promises, right? Is there anybody that has any question? Any question?
Please go about
Hello?
that final again.
You say?
The final.
Let me talk about the finally again. Hello?
Yes. Yes.
Okay, okay. So the finally is always going to execute whether you resolve or there's a reject. So whether there is a resolve or reject, final is always going to run. Okay. So final is like saying whether you resolve or you reject, always run always run this code. Whatever I put in the finally block, right, is going to always run. Even if there's a there's even when there's a resolve or a reject, the final is always going to run. So um if I put the finally there now and I run that code, you see this 26 is an even number, right? So it's actually prints out even number, right? So, and the result is being called. And then we see the results here, results even number. Remember that I did something here, right? So we have results even number. But then after printing the results even number, it's skips the catch, right? But then it executes the finally statement. But then what if I pass an odd number like 25, right? When once you pass an odd number like 25, what is going to happen is it's since 25 is going to call the reject statement, right? So that's a reason for rejection is going to be passed to the catch block of code. So that is why this is what is going to run. But then after the catch block of code running, the finally block of code will also run. So in that case, if I try to run it now, you see the error is being printed out there, right? But then or the reason why the promise didn't resolve is printed out there. After that is being printed out, the next thing is you still see that executed, which is the result of the finally statement. So the finally is always going to print or is going to execute whether or not the function or the promise returns a resolve or a reject. Someone asks if the secondary is necessary. No, it's not necessary. It's up to you. If you want to, you can do whatever I want to do here now. Of course, you know that if we remove this, right, you can simply console.log this instead of returning it to the next. Then you can just say console.log console.log um then you can put that in there. It's still going to work perfectly well. Let's say I pass in 24 there, right? uh it's still going to work perfectly well. So it's not necessary, right, that you must put that second dot then, okay? But it just depends on what you want to achieve. I hope I've answered your question.
Yes.
Okay. So there's there's also something called the promise.all and promise.race, right? Now, there are sometimes that you have multiple promises, like let's say 5 promises, right? And you want to return or you want to get a result only if all those, maybe let's say those 5 promises execute, right? The whole five executes and the whole five actually resolves, right? That's when you want to get a result. Okay, so if you want to do something like that, you would use the all method, right? The all method is used to check if all the promises which you are going to pass to the method as an array, if all the promises have been resolved, then you can maybe call something else, maybe call another code or all the stuff. But then if, let's say, out of the 5 promises, one fails, then that's the then function you're trying to call for that particular promise won't run. Okay, so let me see how I can actually create this, right? Let's see. Let me duplicate this code. Let's just assume that we have this code running like twice, right? and then I want to check if the two codes resolve, right? If the first one and the second one resolved, then that's when I would want to like do something, for example. So this is how I'll do that. I would say promise.all, right? Now, remember what I said about this all. The two or the number of promises you want to check, all of them have to resolve before you can get a result. If not, you won't get a result. Instead, you will get a reason for why that particular, those all like the promise that actually failed, you get a reason for why that particular promise failed. Okay. So this is how it goes. You say promise.all, and then inside here, it accepts values which are going to be an array, right? An array of promises, right? Then let's pass that array in there. And remember that we have to promise check if even, let me say check if odd, for example. And if you want to check if something is odd, we'll do something like this. If after dividing by 2, the remainder is not equals to 0, then we'll resolve that this is an odd number. Odd number, but then else we'll resolve that this is an even number. I don't know if you guys understand the promises I've written. This one resolves only if what you passed in is an odd number, while this one checks if and resolves, right? If what's the number you passed in is an even number. Does it make sense? Hello?
Yes, sir. Makes sense. Yes, sir.
Okay. So if you want to do that, you'd say check if even, and then you pass the number, let's say 22, for example, comma, check if odd, and then inside here you can pass in 21, right? Then after that, you want to do something if all of them have resolved. But if all of them didn't resolve, you might want to do something else. So you can do this. You can say dot then, and then I'll just say VAL, or let's just say RES. I like using RES. Resolve. And this is going to contain, this RES is always going to contain the result of that particular promise, like the result for all the promises that you're trying to check, if all of them actually resolves. Okay. So this is how you do that. If you want to check for the result of all the promises, which will be what is returned here, you can say console.log RAS. So it is going to tell you even number, odd number. Okay. But then if maybe one of them actually fails, you can use .catch to trap the error. So we can just say ERR, then in here console.log ERR. Okay, so at this point, let's test what we've done or we've written so far. So yes, so what happened here is check even actually resolves, right? It didn't reject. Then check if odd also resolves. That's why RES has the result of the resolve function for both of sorry, RES, yes, contains the result of both promises, Okay, but had it been one of them rejected, right? Let me pass 22 here. So we have 22 and 22 here, right? And we all already know that this is the one that is going to reject. So if we pass that in and then we run that code, okay, you see that this odd number, this one here, right, is rejecting. And then the reason for it rejecting is because the number we passed here to check if it's odd is not an odd number, it's an even number. So that's why it is showing us this number is an even number, because 22 is an even number and we want to only resolve when the number is odd. Okay, so it returns that reason. But then if all of them, if all the promises, right, like the two promises I passed in here, all of them resolve to um let's say all of them resolved, right? None of them rejected, then um we won't have this error here. We won't have any um error. Instead, the dot then, right? The fulfillment of that promise, right? And the result is going to be printed out here. But then um if we had an error, or if we had a reject in any of the promises we are trying to check here, then that's when the catch is going to run. Okay, so let's run this one more time, right? This is the result of this particular function rejecting, right, or giving a reject state back, right? So that's why we are having this. But in case I pass in 23 there, right, and I come back here and I call it, you see, it gives us back the results in an array form. Okay, so with what I've done, is there any question? Does anybody have any question to ask? Hello? Anybody? Or is it confusing?
Please, I want to get something clearer. So the purpose of the promise, is it just to handle errors alone?
No, it's not to handle errors. It's to either get your result or um gets an error, right? If what you're trying to check is not resolved, right? If what's okay, think of this promise as think of this function as a function that returns a promise that tells you, I promise you I'll give you back an even I'll give you back a result of even number if I am resolved, right? But if I am not resolved, right, like let's say I couldn't fulfill my promise, then I'm going to send you back a reject. So that and then the result, the reason I'm rejecting it would be error. This number is an odd number. Does it make sense?
Yeah, yeah.
So you can use this to always get either you can use it. So now the reject is going to be sent as kind of an error that you have to handle. So you can decide on how you're going to handle that error, for example. It's up to you, right? If you want
Okay.
to if you want to do something for a party, you can check if the error is an odd number. You can do something. If it's not odd, you can do whatever you want to do on the error. It's up to you to handle it. And also you can also do like whatever I want to do to when you have a resolve. So when everything goes well, you can decide on what you want to do, right? And then it all just makes it possible for it to not just run one promise, but run a list of promises and only execute something if all those promises actually resolve.
Okay.
Yeah. So that's how the whole thing works. So Do you have any other question? Do you have any other question?
Is understood.
Okay, cool. No problem. Okay, then so this promise dot all is going to wait till all of them is being resolved, right? So let me do something. Let me try to delay a promise for some times before resolving it, right? So before resolving, I want to set time out. Set time out for like 4 seconds, and then I'll do that. Let's see. So it's going to wait for 4 seconds, then it's going to resolve, right? Because it has to wait for all the promises to actually resolve before it then gives a result or a reject, right? Okay, it's going before it even gives a result, right? It's going to wait for the promise to resolve. Now, what is happening here is that on this second promise to check if the number is odd, I just set a timeout to delay the response of the promise, right? And then the result for the response, right? And then here we are checking the two promises. And then while checking the two promises, this whole code waits, right? Waits for 4 seconds before it returns the result, right? I can even decide to delay this one. In fact, I think I should just delay the whole thing. Yeah, I can actually delay the whole thing because let me do that. Set time out. Yeah, delay is not denial. So let me put that in there, right? And let me call that code again. It takes 4 seconds before it resolves. Even if you put in, let's say 22, which is an even number, it's going to take 4 seconds before it returns back. Sorry, it's supposed to take 4 seconds, then it returns it returns the reason why that number is, or why that particular um promise, this particular promise failed. So, right, you see now it has to wait for all the promises to resolve. So even if there are like 5 promises and one of the promises takes like 10 minutes to resolve, it's going to wait, right? But then what if we can take advantage of the first promise that resolves, and then we don't bother about the rest of the promises that resolve later than that first one? So how will we do that, right? Now this promise dot race, as the name implies. So promise dot race is going to just wait for which promise executes first, right? Or is fulfilled first, and then it then uses that promise to do to send back a result, right? And then the rest of the promises can actually just wait around, and then whether they are resolved or rejected, I don't think it really concerns the race again, right? So how is this? How does this race actually work, right? You see that I didn't change anything here, right? Everything is just basically the same. What I just did was change the promise dot all to promise dot race, right? So promise dot race is just going to return a single promise, and it's going to return the promise that first um either resolves or rejects. So if we run that now, right, you'd see even number, right? That why did you return even number first, right? Is because this is the first one. This is the one that actually sorry, excuse me. This is the first one that actually runs first, right? Or executes first, or gives out the result first. Then before this check if odd, remember I delayed check if odd by 4 seconds, right? So that's why. So this one is like, it's the way I usually think of it is when I see promise.race, the first thing that comes into my head is on your marks, set, and go. Then whoever resolves first is the person that is the winner. Then the rest can still arrive later on, but then the winner is the person that we actually consider, right? So if I run this again, you see, right? The even number is already printed, but it's just waiting for this one to finish its work, right? But we've already gotten the results that we are looking for. But then let's see if I pass 23 in here, right? Sorry, that didn't save first. So let me run it again. You see, we passed in 23 and it got the, since it's executed first, right? But it returned a reject. Um we got the reason for why that particular um um promise actually rejected, and this is the reason. But uh the difference between race and all is just that all is going to wait and make sure that all of the promises resolves, right? And if all of the promises resolve, then it is going to actually um return the array of like results for all those promises. But then if one of the promises that you're trying to uh execute returns a reject, for example, then that reject is going to be passed to the catch block of code, and then the catch block of code is then going to, you can use that error that's passed to the catch to do whatever you want to do, right? You can check it, you can log it out to the user, you can use that to do whatever I want to do. Now, the reason for talking about promises extensively is when you make a request to a server, for example, right, using JavaScript, that request is always going to be a promise, right? Let's take, for example, you're a front-end developer, you're using Axios or you're using Fetch, for example. You make a request. That request is always going to be a promise, right? And then if the promise resolves, you're going to get the status code of 200, you're going to get the result of what you actually search, maybe queried the server for, right? But then if if you get maybe a 500, right? The server by right is supposed to send, okay, yeah, the server is supposed to send that as a um reject, right? It's supposed to send it with the status code of 500 and the rest, right, as a reject. Then you can use that to, you can say if um you can check for an error using try and catch on your front end and say, okay, if the status code that came back is 500, or if there is an error, your catch, then you can then decide to say maybe error dot title or error dot message, and then maybe log that out to the user. That, it just depends on you, and it depends on how that server, right, the backend was written, right? So most times those things come, if the response, right, if the status code is not 200 or 201 or 202, right, it might then come back as uh sorry, as a rejected promise, something like that, as reject, right? It's not going to come back as a resolve. So that's why most times that, or let's say every time when you get back a 200, it doesn't come um it doesn't come as an error. It comes like in in your then statement. It doesn't come in the catch, right? But most times, if you have something that's not maybe is 500, for example, or 502, I guess it's going to come back as a reject, right? It's going to come back under the catch, right? So that's it. It also happens when you're querying a database as a backend engineer, right? When you're querying a database, right? You can send what the query you're sending to the database, right? You're sending it as a promise, right? And then or the database is going to receive it as a promise, right? And then it can send you an error, or it can resolve and send you back the results of what you are trying to query query the database to get. So that's basically how you can actually use the resolve and the reject in real life, like using promises in real life. That's how they work out. So if you don't use them, if you don't know how to use them at this point, well, then you might struggle a bit when you're trying to, um, let's say, write server-side stuff, or trying to query a database, or trying to maybe work with APIs and the rest, because most of those are actually they are promise based. Okay, so then you can also use async await for promises. Okay, so you can use async await. Um, let's see how that works. So instead of you using .then or .catch, you can use async await, right? And then any function, any function that is marked async or await is mostly a function that's going to return a promise, or if a function that has promise in it, for example. So let's see. How do I use async await with this to call this and then maybe resolve something, for example. Okay, let's see. Let me try to do it with without the async and await, right? Let's see. Okay, DA Cat, you say you have a question.
Okay, sir, thank you. Please, I want to ask, based on the just concluded promises you wrote on the promise.race, now, does the rate only affect the even number or both? Because the output has only been on the even number so far.
Okay, okay. So now, um, you're asking if it affects the even number alone. Okay, now the reason why it's affecting the even number alone is because this one is the first one. Like this is the first promise to win that race, right? This is the first promise to win that race. What when I mean the first promise to win that race is this promise executes, but this other one takes like 4 minutes. Sorry, 4 seconds before it executes. Remember that I put a set time out here to make that to delay the promise, right? So because this one executes first, whether it resolves or it rejects, what its value is going to be what is going to be outputted here. For example, let me delay this function. Let me delay this whole one. Let me delay this one by 5 seconds, for example. So I'll use set time out. I'll say 5 seconds, and then I'll paste that piece of code there. Let me run the whole thing again, and then we'll see what happens. Okay, now have you seen it's now resolving this second one. Now let me pass in an odd number, let's say 23. And for example, right? And then let me pass an odd number. What do you see? What, just check. You see, it has resolved this one now, right? And since I passed in an odd number, it's now showing odd number there. Now, why is it that is this one that is actually outputting? It's because this is the first function, this is the first promise to return a result, right? So let's look at it this way. These two promises are in a race against each other, right? So the first promise that wins the race, that executes first, right? Before, okay, now look, if you let's see, you have check if even and you have check if odd. Check if even wait for 5 seconds. Check if odd waits for 4 seconds, right? So if this code is executed, check if odd is the promise that is going to be executed first, because it waits for around 4 seconds to execute, right? But then after this one has executed, right? Then after 1 second, that's when this other one will execute. So since this particular one is the function that wins the race, right, is the one that is executed first. So the result of this function is what is going to be outputted here. Okay, do you now understand it?
Yes, I do, sir. I understand.
Yeah, so it depends on which actually executes first. If one, the one that executes first is the promise that executes first is the promise that it's like we are going to get the results, or the resolve or the reject from. Then whatever
And both
else
can't be on the same timeout.
you say,
Can't the both of them be on the same timeout? Is it possible, or there's a rule guiding it?
yeah, it's me guiding it, sir. It's me giving it I've not tried it with the same time out before. So, but let's see what happens if the two of them are on the same time out. Let's see. Okay, so if they are on the same time out, then the first promise, this this first one is the one that actually executes. But um that's funny, because why did they choose the first one, right? And leave the second one, even if the two of them are, well, race is always going to just pick one. It's not going to give you an array of results, right? So the two of them executes at the same time, but then it will just pick the first on the list, which is check if even, right? So if I pass in like 22, for example, it's going to print out even number, right? Okay, sorry. Let me run it again. Yeah, it prints out even number. So,
Okay,
but
sir. Thank you very much.
yeah, but the main reason why, like, one might execute like after the other one is if the how do I put it? The second one, right? If you have two promises, like promise A and promise B, if promise A executes first and promise B is still waiting to be executed, then promise A's result is what is going to be sent out. Okay, do you understand?
Yes, I understand.
Okay, does anybody have any other question about promises? No other question. Okay, cool. um so let's continue, right? So I wanted to talk about async await briefly, right? So let's see. If I have a function here, I'll just say call. I'll just call that function call, right? And then let me delete one of these because I just need one. I'll just call that function call, and then on this function, I'd say console.log console.log check if even. Check if even, and I put in there 2, for example. Let's try to print this. Nothing happens because I didn't call the function. So I'll write call that way. Okay, so now the promise is pending, and then after, when it's fulfilled, we don't see any results. Why is that happening? Right now, remember that a promise has its pending state, right? And it has the fulfilled or rejected state now, right? But then you're trying to use this promise, right, in a function, and that function is not marked as an async function. So you won't be able to get easily that the result of that function, right? Except maybe you write dot then. If you write dot then in here or somewhere outside, I think if you do something like this, let's see. If you do something like this, paste that, say dot then r console.log r, and then let it save. Okay, so that resolves, right? But then, so what if you want to execute like let's say you want to execute like 5 different uh promises, right? And you want to execute the second promise after when the first promise is executed, right? I think I should do something like this. I should take everything back to, I want to show that second promise. Okay. So we now have 2 promises, right? And then I want to execute this second promise, right? After when this first promise is executed, right? How do I do it? If I want to do it here now, I'll now say check if even. Then after writing check if even, and then I console.log the result of that check if even, I can come down here and write check if odd, right? And then I can pass a number, let's say 23, and now write dot then here I could say RAS, for example, right? Um, I'd say RAS, and then I would say console.log RAS, for example, right? Then let's execute this code and see what's going to happen. It's going to work perfectly well, right? Even number, then the next one, odd number, is going to show up, odd number. But then this is not really like should I say it's not really readable to me, because having a object, right, the dot then, right, nested in another then, and the rest, like having to resolve the promise by nesting your dot then and the rest, right? This is not really um readable to me. I if I look at this code to pain me in my eyes. And also, if we decide that we want to resolve this particular one outside, so anyone can actually resolve, right? Did that code even save before before I run it? I don't think it actually saved. So let me reduce this one to 2 seconds. Let me run the code again. Odd number executes first, and then even number executes first, right? But what if I wanted them to be in order, right? So even if the odd number is supposed to execute right first, sorry, even if the odd number has a shorter time to execute, but I want the even number to execute first. So that means I'll have to nest this in here. I have to put it in there like that. And then if I come back here, the even number is executed first. Then after this, the odd number is then executed, right? So that's like my control of flow. But if I don't care about which one executes first, right? I can put this one outside, right? But then if we have 5, let's take for example 5 different promises, and then we want them to execute in order. So the first one should execute, the second one should execute, the third one should execute. So that means I'll have to nest each of the promises in itself. So if I want to write another promise here, maybe I want to call even again. I'll now write check even here, right? And then I'll pass in 4 and now write dot then, right? If I keep nesting this, right? What some people say, I think this is the callback hell, right? Trying to pass different callbacks at the same time into your dots then, right? Passing another callback inside another callback inside another callback. And if you look at this, it's not pretty anymore, right? Your code is going to be difficult for people to read. So I could write RRRR, for example. Then let me run it and see what the result is going to be. Even is going to come first, odd is going to come second, then even is going to come third. You see? But then this is not actually fine, right? So how do you still consume your promises, but then without nesting them this way that looks very ugly, right? The simple thing to do is you make this function an async function. So you say async function, and then inside here you can then start to write await. Now await is a keyword that is always going to be used in an async function, right? So the await is like saying the await tells the function wait for this particular code to execute before you go to the next code on that block, right? So if we have maybe 5 promises and you want them to execute in line, right? One by one till the end, then you're going to use the await. Then this async just signifies that this function here, this call function is going to return a promise, or is going to use a promise, right? So if you want to do that, you can write something like this. You can say console.log then you can say await check if even, then you can pass in maybe an even number, then you can say check if odd, check if odd, then you can pass in maybe 3, and we can still call check if even again, check if even, then you pass in 10. Okay, so let me call that and see how it is going to execute. So it's supposed to execute the even first before the odd, then before the even. Okay, so now this is a more prettier way of writing the same thing, right? But then I know someone is going to ask, okay, but then if we are executing using await async and await, right? Right. Instead of using the denable statement, right? Or the denable function using .den, we use it this way. How do we catch errors, right? Let's take, for example, I pass in an even number to this check if odd, right? I pass in 4. So it's going to check if even, then check if odd is going to return, right? It's going to return an error. So how do I resolve this error now in here? Okay, so the simple way to actually resolve that error is to wrap your code in a try catch. If you just type try C, you see try catch as a code snippet there. You can then press enter. So then after doing that, you can paste your code there, and then down here, you see, let me take this back a bit. This is how your try catch looks. You try to do something, right? And how this try catch works is you try to do something here. If anything you're trying to do here generates an error, then you can catch that error here and then maybe output it to the user. Okay. So if we paste our code here and then here on the catch, we come and write console.log error. We are going to see that if we call this code, that piece of code, the first one runs, but then the second one has an error, right? Then the error is that the number we've passed in is an even number. But then after it has printed that error, the code doesn't continue to execute to the end. That's just how it's being designed. When once you use your try and catch, right? And then it's the same, is just basically the same thing with how we used our dot then. If we try to call more than one promise, it's still going to be the same thing. It's going to, if it encounters an error, right? It's just going to pick that error and then send it back, send it out, and then to stop the execution of that code. So, but let's just use one for now. So if we call that, it's going to print that is an even number, right? And then it's, sorry. If we call it now, it's going to print this, that is an even number, and end that code, right? But if we put in 5 now and we call it again, just check, it's going to print out the error, right? So now instead of using the .then, you can simply use this method to write your promises, right? To consume your promises. So this is our promise, our produced promise, right? Or let's say our written promise, right? And then this is how we are consuming our promise. So you can use .then, the denable statements, right? .then. You can also use async and await to, let's say, consume your functions or your promises, sorry. Okay, so these are the major ways you can actually use your promise and consume it. Is there any question? Okay, someone is asking why why the code terminated when it encountered a problem. That's basically how your async await works, right? When once it tries to execute a set of promises and it encounters an issue while executing them, it will simply break out. It will simply break out of that code. It's going to pass the error, right, to the catch statement, and then it's going to break out. It's not going to try to continue to run that code till the end. That's just how it works, right? And then also here, we can have the finally statements. We can have finally here, right? The same way we had finally using dots, then dot catch, then we had dot finally. You can have, you can use try, catch, and finally, and the finally works the same way as it worked before. So the finally is always going to print out, right? Whether it's going to execute something, whether we encounter an error, whether the try statement, right, finished executing, or an error stopped the try code from executing completely, and then maybe the catch was called, right? Irrespective of what happened, right? The finally is always going to execute. Is always going to come up. So I could just say finally here, then I'll say executed. Coming back here, if we run this code, you'd see that, yeah, we have an error, but then after having an error, we have executed there. If I pass 4, which is an even number, right? And we run the code, you'll still see that we have even number, and then we have executed there as the result. So I think I see something on the chat section. Must async contain promises? Can async work without promises? Okay. If you're not going to use async in your code, right? Sorry, if you're not going to use a promise in your function, then there's no point writing the async, right, and the await, because this is going to only work if you're going to, or this is going to be useful, right? The async and await is going to be useful if you're going to use promises in your function body, the body of your function, right? So if you're not going to use promises at all in your function, right, it's not going, for example, if I do something like this, console.log hello, for example, and I come here and write await, this await is useless here. If I hover on it, it will tell you that await has no effect on this type of expression. So nothing, it's just going to always print hello, and it will run the executed finish. It's going to just ignore that await that I've written there. And this is the same thing as removing this await and removing the async. It's basically the same thing. So you run it, it's still just basically the same thing, but you're going to mainly use that await and async, right? When you're going to use promises, something that has to do with promises in your code. Now, if you're writing backend, right? Or when you're writing backend, when you're going to make a query to the database, for example, you want to get list of users, you do something like, this is how it will look. You write const users should be equals to await. Then you now say maybe users table or users collection dot maybe find, right? But this is going to be an a promise you're trying to consume from the database. So now if you do that, it's going to return all the users. Then you can then respond to the maybe an endpoint, right? You can send a response to an endpoint with this user or this set of users, right? But if you didn't include the await now, right, this is not going to print out the result of define. Okay, let's take, for example, let's take this back to how it was before. Let me put 4 there and let me remove this await statement, right? Let it look like that. Check if even, and then we just write 4 inside there. It's not going to give you the results of what you're looking for. To just show promise pending, finish, executed. But the results at which you're looking for, whether it's if it's a resolve or it's a reject, right? Is not going to show it to you. Let me remove this. It's not going to show it to you because you didn't specify the await, right? The await is like saying, wait until this sends a result back, then you print it. If you don't put the await, right, what is going to happen is that it is going to print as soon as this line of code is executed. This promise of pending, right, is the state of that particular of this particular function, right? It is going to print out that state and then wait for 4 seconds. After 4 seconds, this line of code was already executed. So what it's going to do is just come to the finally and execute the finally. It's not going to try to wait until when this result is gotten before it then sends it back to the user. So, but then for you to make JavaScript understand that it has to wait, this is a promise. It has to wait until this promise is either resolved or rejected. But then if the promise is resolved, then it should then output the result of that resolved promise. Then you have to add the await. So if you add await now, right, and then you come back here and you run that statement, you see that it waits, actually doesn't execute. It waits, then once the result from that promise is sent back, it then prints it out and then it continues. So someone is asking where I saw the pending object, right? So remember that this is a promise, and this promise has different types, right? Or it has different states, not types. It has different states. So at the point where that promise is not yet resolved or rejected, then that promise has a state of pending. So while the promise was pending, right, and then the state was what we had here, was what we could actually lay our hands on. Since we did not add the await, right, this particular line of code is just going to print the promise state. It's not going to print the result of that promise. But then for you to get the result of that promise, you have to write await. Await is like saying, please, can you wait for this promise to either resolve or reject before we print out a result. So a typical example, let me relate it with real life. When you are loading something, right, to a vehicle, let's say you're traveling, right? The person driving, the driver for that particular vehicle has to wait for his passengers to be complete before he then moves, right? So what will happen if he just came and parked, and whether there is any passenger or no passenger, he just moves, right? So he might end up moving with an empty car, an empty bus, right? But then he has to wait for the passengers to reach a certain number, right, before he can do something. That's the same way this await is. This await is like saying, we are waiting for this promise to execute, to return a result, right? And if this promise resolves, then we can then execute this console.log with that result that promise has returned. So what if someone is asking if there are 2 or more errors in the promise? So if there are 2 or more errors in the promise, it is going to pick the first error and is going to pass that first error to the catch block. right? Then when the catch block runs, right, it's going to run the finally block, and then it's going to exit, right? Then if you resolve the first error, right, then it's going to, when you run that piece of code again, it's going to print out the second error, right? It's going to pass the second error to the catch, and then the catch would print it out, and then um, the final is going to be executed, and then the function is going to be um complete, like executed and then exited. This is what I mean. Let's say I have 5 here, right? And I copy and paste, and I have 7, for example, right? Now, let's see. Let me execute this. Let me give that first, and let me give this second. Let's see how that is going to work, right? So I call the function, it's going to print even number first, then it's going to throw an error, right? So this is an odd number, right? So it has it's tried to execute this, right? But then this one returns it rejects actually. So that's why we have this an odd number. But then now look at this. If I resolve this one, let's say 6, for example, and then I come back and run the code, it's going to show even number first. Then this one now is going to have an error. So that's why this line 17 now, right, is the one that is giving us the error now, right? If I now resolve that, let's say 8, and I come back and run this code, everything will run fine, right? So this try is just saying, try and do everything I have here. If any one of this code, right, gives an error, stop executing at that line, and then pass that error, right, or the reject, pass the reason why the reject occurred to the catch block, and then the catch block do whatever I want to do inside there, maybe console.log the error. And after console.logging the error, you can then say finally. So this finally, remember, finally is going to execute whether there is an error or not. Okay. So I hope I've answered your question.
Yes, sir.
Okay. So that's how that's the basics of promises, right? So you can use, there's still promise dot any, there's promise dot there's promise dot any, there's promise dot all settled, and there are others which we would look at in our subsequent classes. And then for people that really want to understand NodeJs basics, right? And I think in the next class, you should look at um the FS library, right? You can use FS to create files, read files, write to files, and do a lot of things. And you can use that for automation, right? So you can read from another file, or you can read from several files and then write to maybe one file. Let's say you have 5 files and you want to read results from those 5 files and then put it on one file, right? You can use FS to do that. And there are other uh, libraries that we're also going to look at. Okay. So this is like where I'm stopping for promises, right? The basics of promises. Okay. Is there any question? Any other question? Yeah, okay. Timothy Alabi is asking, can we handle each promise error on its own? Okay. Yes. Yes, that is possible. But if you're going to handle each error on its own, then you won't use try catch, try catch, try catch, right? You won't use try catch. Um, you would use, I think you would use a throw, right? So what I do is mainly I always resolve everything that has to do with error using my catch block, right? I don't try to resolve all my errors one by one. So I'm not really familiar with writing throw and using it like every on my code. So I prefer and I'm used to having try catch and finally rather than trying to handle the errors one by one. So all the errors, what I mainly do is there's always a middleware on back end I pass, right? So I'll just say next, and then the next I'll pass in the error into the next. So this next is going to pass that error to an error handler, and then I can decide that for whatever kind of error that occurs, right? I can decide to do something with it. I can decide to send that error to my email. So whatever error occurs, just send it to my email. Or for whatever kind of error that occurs, I can check if the status code for that particular error is 404. If it's 404, I can return not found. That's mainly how I don't really do it one by one, right? Maybe check if the first one has executed, then check if the second one has executed, and the rest of those stuff. So but then I'll check how that's been done using the throw, right? And then we'll see how it works, right? But that won't be on this class. But it's possible to do it one by one. That's just the bottom line. It's possible to handle the errors one by one. Okay, so is there any other question? Any other question? Okay, someone said, are we doing projects at the end of the training? Yes, definitely. You can't escape from doing projects. You definitely do them. Okay, someone Timothy Alabi is also saying thanks. Yes, lastly, my assignment hasn't been marked. Okay, if you're talking about the third assignment, right? Or the third task, which is the cat simulator. Yes, there are a lot of people that it hasn't been marked yet. So I'll take out today, right? Immediately after the class, and I'll resolve them. Okay. I'll just take after the class, it will be resolved. Okay. Madam Nki Ruler is yes, I know your assignment is still pending. And I know that you put in so much effort to, get it done. Yes, it's going to be marked, right? You're going to be graded again. Okay, so I have not forgotten you. So I'll definitely do that. Okay. So is there any other question? Any other question?
Yes, I have one question. In the last class, what I
Okay.
want to ask, I thought it's the right thing to clone a repository before pushing?
Well, if you clone a repository, yes, you can do it that way too, right? If you create the repository online, then you clone it, then after cloning it, you add whatever I want to add to that, to the to the local repository, then you now push.
I'm
Is
asking, why did you not clone before you add? I'm asking.
okay, why I did not clone it? Well,
Yes.
so the reason I did not clone it is because I didn't want to start the repository online, then bring offline first before trying to add things. I wanted to start them separately, start the one offline separately, that's the local repository separately, then start the one online separately, then see how to actually bring them together, like push from the offline to the one online without cloning.
Okay. Now,
Yeah.
when you clone a report, I said there's something you mentioned before before the end of last class. I said when you clone a report, that means you have a copy of it, isn't it?
Yes.
Where are those copies? One will be at GitHub. The other one will be where?
The other one will be offline now, since you
Okay,
cloned it.
offline. Okay.
Yes, it will be
Okay.
on your system. Remember that you copy
Okay.
the
Okay.
link online, right? And then when you come to your terminal, you now write git clone, then you now paste the link. So when you paste that, when you write git clone, then you put the link there and press enter. That's it's what happens is it goes online and it copies it creates a copy of that same repository online, and then it gives it to you offline.
Okay. Then the last one, I want to get clarification. What is the difference between master branch and main branch?
What's the difference between master branch and main branch?
Yes.
There's no difference actually.
Okay.
So the reason why you have master and main is master was what came out first, right? Master was the name, the default name before. But then the people that the owners of GitHub, right, and Git, they found out that people were always having this mentality that like the master branch is special, right? And then other branches that are not the master branch are kind of like the slave to the master branch, which wasn't actually what they which wasn't true, right? So what they basically did is they found a way to for people to rename their branches, right? And they made it like, should I say, default, that when once you want to push, you can rename it. It's by choice. If you still want it to be named the master branch, you can name it master branch. But to rename it to the main branch too is also fine. There's no main difference between the master branch and the main branch. They are just basically the same thing.
Thank you.
Yeah. So people like deploying their code on the master branch, or sorry, on the main branch, or yeah, master branch. Or some people can decide to deploy it on another branch, right? Some people have the main branch, the dev branch, the DevOps branch, and the rest, right? And then once they finish, maybe on once they push, right, they can push the particular branch, and then some other people can pull from that branch to their own branch and test, and then maybe send it to another branch like that. So that's just it. There's no difference. It's just the name to use to differentiate which branch is used for which. For example, you can say all the devs push to dev branch. Nobody should push directly to main branch, right? So the main branch can be used for deployment, right? And then the dev branch can be used for everything development. And then it maybe the dev branch can be deployed, but not deployed for people to use generally. But then the main branch can be deployed for people to use generally. Oh, DA cat, you're lost, right? Why are you lost? What is it that you don't understand?
So don't worry, continue. It was based on the assignment, but I'll catch up with them.
Which of the assignments?
It was based on the first tax, sir. I wrote the exam, that was why.
The first task, let's const and var.
No, sir, that was tax 0. Oh, sorry. The second task, sorry.
Okay, which is the CLI guessing game.
Yes, sir.
Okay, so the CLI also guess a number between that 1 to 10 and also compare what you guessed with what it generated. If it's the same, like let's say I guess that the number is 5 and Node.js guessed that and Node.js generated the number 9, right? So the numbers are not the same, so that means I didn't pass, right? But after it shows I didn't pass, it shouldn't exit the code. It should still ask me like another number to guess another number. Then let's say I guess the number 8 and then 8 was generated by Node.js. It should then tell me you have won. So that you have won means yes, I guessed the same number that Node.js guessed, right? And then after that, it shouldn't exit the code. It should still ask me to guess another number, right? And so on and so forth until maybe when it asks me guess a number and I type exit and press enter, then it can then tell me goodbye or bye-bye, and then it should exit the code. That is the simple way it should work, right? And I remember I talked about recursion, and to keep your code running, that's without exiting, you use recursion to actually keep it there. Okay, are you clear now?
Sir, I did not do the math.random method. I used the prompt method, which you used in the last 3 or 4 classes. That was what I used.
You used what? You did not use math.random, you used prompt. Does prompt generate random numbers?
So that was a mistake I made, which I'm going to go and rectify it.
Okay, cool, no problem, do that. All right, okay, so let's continue, right? Now, as a backend developer, you're going to develop more of APIs, right? And you're going to develop more of RESTful APIs, right? Now, what is a RESTful API? What is REST? First, let's start from there, right? What are RESTful APIs, right? So REST is the short form of representational state API, right? Representational states, right? So how does RESTful APIs work, right? Now, while writing a RESTful API, have it at the back of your mind that whatever you're writing as a RESTful API doesn't keep the state of let's say the user that's maybe made the last request. Let me explain. Let me use a real life example, right? You're in a shop, and let's say someone came and bought something, right? And let's say the person has come to buy something like 20 times. But then if you're acting as a RESTful API, no matter how many times that person come to buy something, you don't smile with the person. Maybe if the person, of course, let's say, for example, let's use workplace. Let's take, for example, you started working in a place newly. Let's say the first 2 to 3 days you go there, before you pass the gate, you have to show your ID card, right? You have to show your ID card. You show your ID card. You show your ID card. Then, let's say on the 4th day, they've noticed your face already. So when once you come, the person that is supposed to open the gate for you to pass to maybe your to to go inside the office. It doesn't check your ID card again. It just basically allows you to enter inside, right? Now, that person has recorded your state. The like kind of knows, he knows you, right? So there's a state about you that he has recorded in his mind that, okay, this person is now our staff. So I always open the door for this person, right? And the person is going to treat you that way. But you see, RESTful APIs don't know that. When once you come and you make a transaction with the RESTful API, and then you try to make another transaction with the same RESTful API, you need to provide enough credentials to prove that you are someone that's you're like you just try to prove who you are to that API before it can actually send you a response. So it doesn't keep the state of its customers, right? So comparing a RESTful API to real life is like someone that even if you've worked there for like 20 years, every day you come to office, you must show your ID card, whether you forgot it or whatever. The person doesn't care, just show your ID card, right? But then because that person doesn't want to know the state of you, right? The person doesn't want to have um the person doesn't want to record it that, okay, this person is a staff or this person is not a staff. The person always wants you to show it, right? So that's the same way RESTful APIs work. They don't care about how many times you sent response to a request to them. They are always going to ask you maybe for credentials, right? Or you can't tell a RESTful API, I'm that customer that came just 5 minutes ago, I'm coming back. No, it won't want to remember you, right? So now RESTful APIs are mainly used to as services, right? So that multiple people around the world can actually maybe make requests at the same time and get responses from the same service, right? So we can still compare RESTful APIs to being a waiter out there. It can be public now, and a RESTful API can be public, all right, and it can also be private, right? So it can be public, anybody can send a request to it. It can be private, that only maybe a particular website can make a request to it. Okay, so that's how RESTful APIs work. And then what is an API? Because I have explained what RESTful APIs are, right? I am supposed to even start explaining what APIs are before I even start to explain what RESTful APIs are. But all the same, what are APIs? So I wouldn't want to explain that one now. I want someone to try to explain it first before I start to explain it. So is there anybody here that can try to explain what an API is and what its full meaning is also? Anybody wants to try?
Okay, API means I think application program interface. You explained it when you were explaining the uses of JS, if I can remember. And it's used to make, as in it helps is it applications to interact, something like that. That's if I can remember what you explained in the first JS class.
Okay, yes, you're correct. Yes. So that's a fair explanation to it. Yes. Anybody else wants to try? No other person. Okay. All right. So in the absence, okay. You want to try?
Yeah, I'm thinking is application program interface. That's a set of rules whereby the different software application used to interact among themselves.
Yes, but yes, that's fine. That's also a good idea. But then the API, right, is an interface in which, yes, a service can interact with another service, or let's say an application can interact with a service, for example. So let's take a mobile app, a mobile weather app, right? Let's say I'm building a um a mobile application that should always show me the weather for any location I search for. For example, that application is on my phone, right? But then how do I get the information on the weather condition for a particular location, right? So now that's my weather application, right, on my phone needs to communicate somehow with an API, which is sitting somewhere else in the world, somewhere maybe I might not even know about, right? So if I want to get that information, I go online, I make my research. Oh, okay. After making a whole lot of research, I then find out an API, right? Then I read about how that API is being used, right? So the API tells me, oh, if you want to get the weather information about this particular place, this is how you must send it. You have to send it in this, you have to send it in this format, and then it is going to return so and so results in this way, right? Then if we do that, if we follow the rule to send that request, right, we'll get a meaningful response from that particular API. And then we can then use that response to um, maybe show it back to the user, right? That's the same way websites work too, right? So a website is also an application, right? Right? But it runs on a browser, okay? So then if your website is going to get information from an API, then it has to follow the rules for that API, right? So now that is you using a third-party API, right? But then also you can also write a private API for yourself. For example, what banks do, banks have their private API that is written for them and only them to use, right? Now, comparing it with the weather API, for example, the weather API can be used by anybody in the world, right? Anybody that wants to create a weather app can actually just use the weather API to create one, right? But then the bank, for example, restricts their API, right? Or some certain parts of their API to only their mobile app, right? Or their website. So any other person can't use the same API, right? If you want to get access to that API, then um maybe you have to have some certain rights, or you have to use their app or something, right? Or you have to get certain special privileges before you can use it. Okay, so that's how they work basically. Now I want to test something. I want to show you how an example of how an API works. I have a weather API, right? Which I would want to use. Let me just send the key down to where I can actually get it. Just give me some few minutes. Let me do this. Okay, so let's see how we can use that weather API. For example, let's see how we can use it.
So please using the VS Code screen because we are not seeing anything else aside this other code.
Yeah, sure. I don't want you guys to see it actually. So look at this, right? Look at this. I got this link, right, from weatherapi.com. But then they said that if I must use their API, that I have to send the requests in this form, https weatherapi.com/currents.json. Then I have to pass in a key and the query, and this query should include the location which I want to maybe get the weather reports. So for example, let me take this to my browser and I'll share you that particular screen, right? So let me take this to my browser and paste it. Let me share my browser now for you guys to see. New share. So I think that should be it. Can you guys see my browser now?
Yes, sir.
Okay, so this is the full link, right? And they said that if I must search anything, so let's take, for example, I want to search for the weather condition in London, right? Or let me not go far. London is too far. Let me search Lagos and I press enter. You notice what it's sending back to me? It's sending something in form of, it's sending an object back, right? Now, what is used to identify me is this key. If I remove this key, I can't be identified by the back end. The back end wouldn't know that it is me that's making that request. But then the only way it can know I'm the one making that request is that key, right? So if I change this key to someone else's key and it's still valid to send me a response, right? So I could change this, let's say, where else? Let me go to London, right? London, Greater London, country, United Kingdom, at the latitude, the longitude, and it gives more information about whatever we are doing, right? And this is me interacting with an API somewhere. I don't know where it is actually, but I'm interacting with it. Okay. So now, how do I do the same thing with within my code, right? Now, I'm not writing an API, I'm querying an API. So how do I do it within my code? So if we want to do this, we can use Axios, right? I mainly like using Axios, right? So Axios enables you make requests and then get response back from a server. So let's see how we can then use that our promise that we learned with Axios. Okay, so let's come back to VS Code. Let's come back to VS Code, right? Let's come back to VS Code. Sorry. Let's come back to VS Code. I hope you guys can see my screen, right? So the first thing I need to do is I'll say npm install Axios, right? Axios installed successfully. Then this is how I would use it. I would say const Axios equals to require. Then inside here in strings, I would say Axios, right? Then after that, remember, it's a promise you want to consume, right? We'll then say async function. I know people are familiar with this, but let's just do it. I would say fetch weather. Fetch weather there, and then inside here I can then say const response equals to await. Response should be equals to await axios dot okay. Seeing get adapter. There's always an axios dot get, so why am I not seeing it? Axios dot get, then I'll just copy all this, paste it. But then at this point, I want to get the weather location for Calabar, for example. Then under here, console.log response. Then what I'll simply do here is come down here and call the function. So fetch weather, and then let's see, axios equals to require axios fetch. Let's see if that would run. Okay, so we called that function, and then if we come back here and check what our response is, you see that there are a lot of things we got back as response, a whole lot, right? But then what we are looking for is, okay, we got a status text of 200, we got a status of 200 status text. If you check within this, right, you're going to see data, right? There's always axios.data. Okay, then this data contains everything that has to do with our request, right? The body of our request. So I'm going to explain some few things very soon, but then you see that we've gotten the name, the region, the country, the latitude and longitude of Calabar, right, and other details, and then we were able to get the temperature in Celsius, temperature in Fahrenheit, and other things, right? Weather condition, which is an object, pressure, a lot of other details, right? But then if we want to get only the data, so if we want to get only that data, we'll just say response.data, right? We can get status by saying response.status. So let's come back here and run the code again. Now, this one is going to be shorter. We just have 200 as the response status, and then we have the data, which is this location, current, and every other thing that has to do with what is inside that current. The condition too, we can see is moderate or heavy rain shower and the rest, right? Okay, so but then how is this working out, right? Had it been we didn't put the await, for example, let me remove that await and then we come back here and we run node index. We'll see what happens. Just showed undefined, right? Why? Why did it show undefined? This, we didn't even wait for the Axios to fetch what it was fetching and return it back. We just tried to print out the status and the data. If we tried printing out only the response, right? We still get, okay, we get pending, you see? So while it was still pending, we didn't even wait for it to get fulfilled or anything. We just went to the next step, which is to log out this. But if we put in that await now, is oh, when we put in that await, it has to wait till when this is fulfilled, right? If we search for Eket, for example, right? Now, look at what is going to happen. Oh, look at what is going to happen. Eket did, oh, it's searching for another location, Eket in Oyo, right? But if I search, I don't know which, um, let me search for this particular local government. It's a local government here in Akwa Ibom. Let me see if it's going to get it. Oh, it's still getting it. I'm looking for a location that it's not going to get easily. I'm looking for a location so that it's going to throw an error. Beautiful. So this is what I was looking for. Yes. So it's saying error, no matching location found, right? And it's throwing all this, a whole lot of things. But then we are concerned with the body, right, of that error. So how do we handle this? So we wrap the whole stuff in a try catch. So inside here we can put that in a try. Then inside the catch, we can then say console.log error. So let's see what is going to happen now if we run it. Okay, you see that's okay. The data is still coming back as an object. Okay, with a response of 400 bad requests. If I did error.data, error.data is undefined, so which means I have, let me check this well. Let me check it well. Axios request fail with status code of 400. So let's see, error dots. I think it should be error.response.data. I think that should be in the response. RAS incoming message. I'm looking for where I can get that response. Okay, dot response status text. Okay, we have config. I think that should be response.data. Let me see. Response. I'm finding it hard to get that response. Why? I'm trying to get here, but I can't seem to find it from here. So let me try error.requests. Let me try error.request to see, does requests contain I can't I can't get that error there. But then my point is that I am getting the error, right? I'm getting the error object from here. Although the error object contains too much information that I might not want to, it's not all of this I want to use, right? So I could sit to trace that where that data is from, right? But that would really take time now to actually trace. But then I've been able to catch the error, right? So if there is no location, right? If that location doesn't exist now, you see that I'm able to get the error, and then I can use that error to do whatever I want to do. But if that location exists, then this is what is going to run, right? Let me check. So someone said, please, are you presenting, because I'm only seeing the previous work. Okay. I hope you guys can see my VS Code, because it's VS. Okay, yeah, you guys can see my VS Code. Cool. So we can see that JavaScript is synchronous until one defines the synchronous process. We can see that JavaScript is synchronous until we use promises, right? Or we use async awaits, right? So promises is the pathway into asynchronous programming. It's one of the topics, like in terms of asynchronous programming, right? So once we start using promises, just know that we've already entered the asynchronous programming. That's it. So promises are not synchronous. They are part of asynchronous programming. That's just one thing you need to know. Okay. So going in here, right? You see that the try and catch can help us in different ways. If we have an error, we can log it out here. If we don't have any error, we can decide to do something here. Okay. All right. So now, how do we communicate with servers, for example, or with APIs, right? Sorry, with APIs. How do we communicate with them? Now, we communicate with APIs, with RESTful APIs using the HTTP, right? Right. The hypertext transfer protocol, right? Now, you each and every time that you're going to send a request to um, an API, each and every time you're going to send a request to an API, there are some things you're going to always send with that API. Okay. Now, one of those things you're going to send, right? You're going to send a method. Okay. You send a method, and you will send a request body. You would send a request URI. So I'm going to explain each of these things, right? So for a RESTful API, as a client, right, what you're going to send, like for example here, what I'm sending here contains the request URI, which is this string you're seeing here, HTTPS API with like from here to here, right? Then these other parts after the question mark is the search parameter. Okay. But then all this has to do with the URI, universal resource identifier. So this URI tells the back end which particular service or which particular endpoint I'm trying to maybe get information from, right? For example, if I want to get information for the forecast, right? For this particular weather API, I'll need to change this current to forecast, and then there might be other information which I will need to add. to this URI before it then works properly. Okay, so this is the URI, right? Then another thing I need to send to is the method, right? So we have get method, we have post method, we have put method, we have delete method, we have patch method, like we have other methods, right? Apart from that, but apart from the ones I've listed out, but the ones I've listed out are the more popular and more used ones, right? So now these methods too tell us tells um um tells the API, gives the API more information about what we are trying to do. For example, if you're trying to change your profile picture on, let's say on your phone, let's take for example your Facebook or your WhatsApp, for example, right? You want to change your profile picture. That would probably be a put request, right? So you're sending a put request or a patch request. It might be a put or a patch request, right? So you want to change your profile picture, right? But then if you're trying to register on a website, for example, that would be a post request because you're trying to create, right, your details on that particular server or on that particular service. So so let's see. Let's talk about get, patch, put, and delete methods, right? So the get method is used to get information from a service, right? For example, if you're trying to let's say get a list of something, right? Maybe a list of news or a list of, or a user, for example, or you want to view a user's profile. Maybe you click on a particular user to view his profile, right? Or you just type maybe google.com and press enter on your browser. What you're doing is you're making a get request to google.com. I can do that here, right? Let's see. But it's going to return HTML for me. So I could say https:// google.com, right? And then let me run that code to see what is going to happen. So if you look, right? If you look, this should be the body of the code and it's returning back HTML to us, right? But then since we are not the browser, right? You see, it's returning back a status code of 200. 200 means like accepted, like I'm sorry, okay. 200 means like okay, like I'm okay. I've executed this well, right? Then it sends us back HTML. And if this HTML, right, if this was a browser, the browser would have transcribed this HTML to something meaningful for us to see and use. Okay, but since we are just getting the raw text back, that is why we are seeing it this way. So each time you make a request, right, you're actually making, like maybe you go on your address bar and you type a particular value there. You're actually sending a get request. Okay, then a post request is mainly used when you're trying to maybe create something on a data on a service. For example, if I want to create a post, for example, let's take for example on Twitter or on Facebook, you want to post something, right? They from the name post, right? It's a post request because that thing didn't exist before, but you're trying to post, or let's say that article didn't exist before, or you've not posted it before, you've not done so before, right? You send a post request to create the article for you. Then you send a put request where you have maybe something was already created, but an information was missing from um that let's take for example you try to register on a website, you put your full name, your email, and your password, but you did not put your phone number, right? But then you want to come back and you want to add your phone number to your profile, right? That would be a put request, right? Then a patch request would be you trying to send a patch request to be you trying to, let's take for example, you already have your phone number on that site, but then you want to change it to something else, right? That would be a patch request. But then most times put and patch are interchangeably used. They are not really, it's not really strict that if you use one it won't work, or if you use the other one it won't work. Some people just use put, some people just use patch, right? But then that's the main difference. Then of course the delete is, as the name implies, is used to delete a resource, right? So if you send the delete request to maybe an API, right, it's going to understand that you want you want to delete something, right? Then they when you're sending a request to an API, you're also going to send it with a request header, right? So what is a request header? A request header is just um a request header is used to give more information about a particular request. Like for example, the content type for that request, right? The content type has to do with what type of content are you trying to send to that server? Is your content on a JSON? Are you sending a JSON back to the server? Are you sending only text to the server? Are you sending a picture? So that is a picture will have the content type of multi-parts, right? What are you sending? Are you sending JavaScript to the server, right? What are you sending? So that's where the content start coming. And then this is how if you're using Axios, you write something like this. Then here you would contain the body. Sorry, here would contain the, yeah. Now, get requests don't usually have request body. Get requests don't have body. So whatever I write here is going to be taken as the header for this particular get request, right? But if I change this to a post request, then I can pass a body, and then after that, as an object, I can also pass a header too as an object, right? And we'll see how all these things work, because as a backender or as a backend developer, you're going to accept most of these things, and then you're going to use it to be able to process information on backend. Okay, so you can do this. Then also there's always a request, there's also a request body, right? So now let me apart from content type that's used on the request header, you can also send your authorization key as your request header. Authorization key is just used to identify you, right? You can send it as your header. Now header can be included on any kind of request method, right? If it's a get request, or is a post request, or is a put or patch request or delete request, you can always put your content, your request header. But then on a on using request body, right? If you're using request body, you can't send request body with a get request, right? You only send it with post, patch, put. And I think you can also do so with delete. I've not tried it with delete before, sending a request body with delete, but I think that's possible. I'm not really sure. So that's the basic of you sending a request, right? Then when you're getting a response back from a server, right? If you're getting a response, the response usually comes back with a response header, right? Then you have a status code, right? Then it also comes with the body, or the response body, or some people will say response message body, or but it always comes with your response from an API is always going to come with a header, a message body, and the status code, right? And then status code is another big topic. There are different kinds of status code. We saw that this Google own send us a response status of 200, right? See it here. Send us a response status. I said response the status. It sends us 200. If we check this one sends us 404. If we keep scrolling up, we will see somewhere it sent us back 400. See it here. Status code 400, right? 400. Some will send 404, some will send 500, and this code actually means things. So some 200 means okay, 201 means created, 400 means bad request, 404 means not found, 500 means internal server error, and the rest. There are a lot of them, right? And it's something you guys need to also get familiar with, right? So we would see how this works more, right? So then the last part of this class for today is how do you set up your um how do you set up your Express.js, right? So Express.js is used to write APIs, right? Backend stuff. So how do you set up your Express.js, right? So let me delete everything I have here on this code, right? And then already remember that this is an npm package, right? What I've done, I've already done npm init here already. If you check, I've already done npm init. So we have package and we have package log, right? So I have npm prompt and prompt sync here. Okay, so how do I start using Express.js? For example, how do I start using it? Let me clear out this my terminal. So that's the last thing we would do, set up Express.js. How do we do it? Now, just first install npm install Express. So when you install Express installs, yeah, it's done. You come back here, you see we have Express 4.18.2, right? The next thing for us to do is we'll come to our entry point and say const Express should be equals to require Express, right? Then for us to start Express here, um would say const app should be equals to Express, right? Then the next thing we can do here is we can start accepting requests. So I could say app.get slash, I'll then say req res. I'll explain what I'm doing here very soon. Just give me some few minutes. req res dot send hello, and let me also include one more. So I would say ping and bong there. So what I've done now is I have required Express in this file. I have initialized Express. So this is like me calling Express to start up here, right? And remember that this index.js is our entry point, right? Then the next thing I did is I declared two routes. So let's continue. Okay, so this is what I have done so far, right? So I was trying to explain what I did, right? First, I called Express. Then the next thing was I initialized Express by this is like saying start Express. Remember that when you call a function, right? You can use that function to do whatever I want to do. So here you have to always write this, right? After requiring express, you always have to start express, right? Before then you can then use the values or what the gets, post, and put method and the rest, right? If you don't start express like this, right, then you won't be able to use it properly. Now, I've started express, I've initialized express, I've created two routes, the slash route and then the slash get, right? Oh, sorry, and the slash ping route, right? And the two of them accept only get requests. So how do I send that request to how do I send that request to my back end? Now you can use Postman, but personally I like using an extension called REST client. So if I search on REST clients, if I search on REST clients, you'll see it here. I've already installed it. So REST client helps me to make HTTP requests easily without needing to leave my VS Code. I can make HTTP requests right from the comfort of my VS Code. So this is how I'll do it. If I want to use the REST client, I'll just need to create a file. And that file needs to end with the extension .http. So I could just say test.http, or if you don't want to use the HTTP, use test.rest. The two of them are actually the same. And if you use, but the file extension must end with either .http or .rest for you to be able to use the REST client. So let me keep it as test.rest. So this is how I would send that request. First, you write the method get, then the next thing you write is the URI. So I would say the URI is https :/ localhost localhost : 3000 / right? And since it's a get request, right? Since it's a, oh, sorry, you don't use HTTPS if you're offline, right? Since it's a get request, I don't need to put in maybe, sorry, since I want to make requests to this first one, to this first endpoint, right? I don't need to, whether I put the / or not in my request, it's still going to work properly. So if I send that request, you see the response here. The response comes with the status code of 200, the status text of okay. You know that 200 means okay, right? Then here is the content of the response header, right? And then this hello is the content of the response body.
Anderson,
Yes?
how did you send the request using REST client?
Okay, after typing, the first thing you need to type is the type of request you're sending, right? And then the second thing you need to type is the request endpoint, or the request URI, right? Which is this localhost / 3000. So for me to send that request, I just need to click on this send request button here.
Okay.
So let me close it again. If I click on send request, you see, it sends me it sends that request, and then when the response comes back, it sends the response, right? So here you can see, now this HTTP is the version of HTTP we are using. There's HTTP 1 and there's HTTP 2. HTTP 1.1 and I think there's HTTP 2.1 or so. But there are two versions of HTTP. That's what you need to know. Then the next thing here is the status code of 200, right? This status code of 200 has to do with this response code of 200 has to do with the status code, right? And then this okay here is the response text for that response. If this was 404, this would have been not found, right? Then the next thing you see here is the response header, which has to do with everything about the response. So it's telling you that the content type is sending back is HTML, and the character set for that is UTF-8. Then the content length is 5, which is hello, HELLO, which is just 5. This E tag, it has to do with the tag for that particular response, right? Then we have the date, right? The date and time at which we send that request, and then the connection, right? If this connection was a stateful connection, then the connection here would have been keep alive. But now what we have here is close. So close is like saying, like we've sent you back a response. It's trying to tell the server is trying to tell you that we've sent you this response and we've closed our connection. So if you want to send another request, you have to open a connection with us. So each time you click send request, you're opening another connection to that server. And once the server sends you back a response, it closes that particular connection. Okay. Then now, if we write slash ping, right? If we write slash ping, right? And then we click send request, you see, we get back a pong, right? So you see that we've written a simple API that has 2 GET requests, right? It gets requests for the first one and then the second one, right? Does anybody have any question on what I've done so far, what I've written here? Any question?
Question on how you open the file for the REST client.
This one?
Yes, sir.
You just right click and create a file. I just right click and new file. Then the new file, I named it test.rest. So then inside the test.rest file, this is what I've written inside. Finish. Is there any other question, or have I answered your question?
Yes, sir.
Okay, any other question? Any other person has a question? No other question.
So please go back to the index.js and explain that part. Yes, please do explain it again. Thank you. Because I don't understand this express, to be honest.
Okay, so Express is a framework that is used to mainly accept requests, right, from an application, right, or from a website, from a front end or a mobile app, right? Then it would send back a response. It's mainly used for request response. Now see what happens when you write Express.js, right? After initializing your app and you want to write an endpoint, right? This endpoint itself, remember that you used, let's say, if I name this A equals to Express, I'll just use A here, A here, A here, but I use app equals to Express. So this app here is this Express that has been initialized, right? Okay, so when you call this, it creates an Express application. The Express function is a top-level function exported by the Express module. Now, this function here is exported by default from Express, right? From this Express module that you're importing here, right? So that's why you can just call the Express directly by just saying app equals to this Express name here, right? Just know that what you've written here is you've called and you've initialized Express, right, for this particular folder, right? Or let's say for this particular project, you've called and initialized Express. Now, the next thing you can do is you can start writing your routes, right? So an Express route, you write it by saying app dot, then the method that you are expecting your front end or a client to send. So I'm expecting that if you want to make a request to this particular endpoints, right? That you should make a GET request, right? And then where are you making the GET requests to? You're making it to the root, like kind of saying this forward slash, right? It's not forward slash anything, it's just saying forward slash. Now, everything that has to, when someone is trying to send a request, right? Everything that has to do with the request is going to be trapped in this RAQ. Then everything you want to know about the response of that particular request is going to be inside this RAS. So if you want to send the response back to the user, you're going to use, you can name this full, right? You can name this request like this. Then you can call this response in that way. But remember that if you're going to use response this way, then you're going to come and say response.send here. Okay. So, but if you're going to use RAS or RAQ, you can use it RAQ, RAS. So whatever you're going to call this request, RAQ here is going to hold every, in fact, let me print out this. Let me say console.log the RA request. If I console.log the request. Now, one thing about Node.js is when you make a change on the server, right? You need to come and stop the server and start it again for it to get that change that you've made. So now let me make that request. Let me make that request to this endpoint again, and let's see what happens. Let me delete that, and then I'll come back here and send that request. Right? I still get hello, but now look at what happens. Everything that has to do with the request I sent is here. The origin URL, base URL, the protocol. Okay, all this is null though. But see, it knows that I'm sending the request to slash, right? So that's everything that has to do with the request I'm sending. That's the request I'm sending from REST clients to index. Then the response has to do with the response. What is going to be sent back to who made that request? Do you understand? The whole thing is request, process, response, request, process, response. So for example, if I want to make a post request, right? Although there are some things I'll need to write down here. Let's say I want to make a post request. I need a middleware that is going to, and we'll talk about middlewares too, right? We need a middleware to process that response. So I'd say I would explain what middlewares are in another class. Request, we'll just say app dot use, because this is a middleware. So I would say express.json. So let me cancel this and start it again. Right? So let me do this. Let me say request.body. Or let me just send back the request body for us to see. So I'll just say request.body. Right? Now let me send the response and see what is going to happen. Or let me start this server again. Then let me send the requests, right? And then let me make it a post. Let me make it a post instead of a get. So let me say post at this point. Then come and crash it again, and then come back here. So I'll change this from a get to post. And then remember, if you're making a post request, you always have to tell us your content type. What is the content type? Application/JSON, which is JSON I want to send to the backend. Then I'll just say my name My name is Victor.
Please, can you go back to that index? I want to see the content.
Okay. So can I go back now?
Yes.
Okay. So let's take that, right? And then let me send the request. Did you see? What I just said that the request that I'm sending to the user should be, sorry, I said the response I'm sending to this user should be what he sent to me as his request body, which is everything I wrote here. Maybe if I add something else here, maybe country Nigeria, right? And I click send request. You see, he's sending me name and country as Victor and Nigeria, right? So now that should tell you that everything that has to do with the request is here. Remember that a request contains a request body, it contains a request header, it contains a request method. So if I change this to request dot method, and I crash the server and start it again, and I send that request. Do you see? It's now showing me the request method that I'm using to send that request to Express, right? So now this is to tell you that everything that has to do with the request, right, is inside
I'm
this.
getting error trying to replicate that.
What is the error you're getting?
It's saying cannot post. Error, type error. It's showing HTML tag.
Okay, did you stop the server and start it again?
I didn't.
Did you?
No, no.
Yeah, so it's not going to, you have to stop the server and start it again. For now, I'll show you how to do it without stopping and starting the server again. But for now, just stop the server and start it again. So if we say request dot header, let's say request dot header, I think that's the request dot header. Then I send that, I start the server again, and I post. Oh, it's saying first argument. Okay. Let me crash that again. I think I need to add S in that request headers. So I'd say request headers. Yes. Then come back here, start the server again, send that. You see, the request header contains our content type, which is application/JSON, and some other things, right? The content length is the length of this content, which I have here. The host, which is the host for the back end, right? Like the host where the port is running, and then the connection type is closed. It's similar to what we are seeing here, right? Content type, user agent. The user agent is where we are sending the request from. The user agent is VS Code REST client. So you see that everything that has to do with the request is inside this request object. The request header, request body, request host, everything about the request. While this response has to do with everything we want to send back to the user. So if we want to see the response status code, right? If you want to see the, if you want to see the status code, I think we can say response.status. Response dot, okay, I can't use status this way. Okay, let me see. Response the status. Then let me come and crash the server and start it again. Then send that request. Okay, that's because I didn't pass in any value. So let me come back here and say response.status code. Status code. Instead of status, then let me send that request again. What's going on? Converting secular structure to JSON. What is it saying?
On my own, I got the response of status. I got the headers, but without just the heading part. HTTP 1.1200 OK X power express date connection close content length 0.
That's what you got for the status code or the status.
Status.
Okay. And it's showing 200 means it's working. Okay, status code is showing me okay. So why is it that when I think this thing didn't save before I started running the code? So let me see. Status, right? Response.status. Okay, if I'm calling response.status this way, I need to pass in the status code. So if I say 200 as response status code, right, then it's going to work out. Oh, what's going on? Converting secular this to
Or for my own, I didn't include the bracket as it just stays like that. That's the way I said it.
okay. It's like I have to wait for it to save before I send the it's not working for me. Okay, but then let's leave that out. But just so you know that this response has everything to do with what you want to send back to the user. So if you want to send back JSON, you can use res.json, right? If you want to send back ordinary text, you can just say res.send. Res.send. Then here you can say hello. Then let's come and crash the server again and start it. It's that simple. So that's the basic of how to use a how to use Express.js, right? To send a request, right? Sorry, use how to use REST client to send a request to your Express and then get a response to that particular request. Okay. So does anybody have any question? Any other question? Hello. Everybody's following.
A question from me.
All right. Okay. So this is the basics of uh JS, right? This class has really taken a long time. So that's the basics. That's the basics for JS. Okay. And so if you have any other question, you can always ask me, right? But then we are going to stop here for today. So um in the absence of questions or in the absence of any question, then which means we would see in the next class. Oh, okay. Ben, yes, you would need to absorb everything. So You can't absorb everything. You can't absorb everything immediately as I'm teaching it now. So, which means you have to watch this video again and then try out what I am doing, and then keep watching it, watch, come back, try it out. And then I know it's a lot of information at the same time, but then you need to do it step by step, try it out, and then when you're like when you're okay, right? Then you move to the next thing, right? Gradually, you move to the next one by one like that. Okay, so I don't expect that you grab everything now. Okay, so in DA cat, you got confused from the API, right? You got confused. Now, how the API, right? Now, look, oh, this REST client is acting as kind of a browser, right? This REST client here is acting as kind of a browser. When I click send request, this request here, right? This is kind of whatever you're seeing here is kind of a request, right? This request is sent from here, which is kind of like a browser, right? Okay, it's sent from here down to our Express.js. Now, look, oh, should we have a get request here? Dear cat, just look, we have a ping request here now, right? And it was to return pong. I hope you know you can try this get request on your browser. Oh yeah, let's go over to our browser now and try it. Let's go over to our browser. Let me share my browser screen with you. Um, let me share it now. So, let's say localhost colon 3000 / ping, enter. Oh, what happened? Okay, the server wasn't running, so I'm starting the server now. You see, I said ping and I got back a pong, right? So if I do that again, you see we have a ping, but we sent a ping, but we got back a pong. Now, you can't send a request, you can't send a get request to slash, because slash doesn't accept a get request. Remember, slash accept only post request. If we come back to our VS Code, remember, let me share my VS Code screen now. Remember that this slash only accepts a post request. If I change this to get now, if I change this to get and then I come and crash the server and then start it again, then we go back to our browser, right? Let me share back my browser. We come back here and we run that code again. You see, it now sends us hello. Okay. So, but now, instead of using a browser to try and test, because browser is limited, we can only send get requests in our browser. So instead of using a browser, right, why do we should use something that we can send any kind of request we want to send. That's the main reason why I used the test.rest instead of using the browser. Dear Kat, I hope you understand now.
So with time I'll understand.
All right, cool. All right, so no problem. You will do so. So with that said, we've come to the end of today's class, right? Is there any other question? No other question, right? All right. So in the absence of questions, see you next tomorrow. That's on Thursday. All right. And
No?
okay, so someone is asking how I was able to know all this. I think that will be an off-call conversation, right? So that'll be when I've stopped recording, so we can talk about how I got to know it, right? But apart from this question, right? Is there any other question?
I wanted to ask, can this thing be available today? The video, the replay.
Today,
Yeah.
that is not something I can control because I'm not the person that actually posts the videos on YouTube. So that would be to ask Mr. Ikechukwu, but definitely I'll ask him if it won't be available today, then it will be available by tomorrow. Okay?
Okay, sir.
Okay. All right. So in the absence of questions or any other question or concern, right? So we are done with today's class. So see you next week. See you next tomorrow, which is Thursday. All right. So bye bye.